Hello everyone. Week one, lesson one. We're going to lead off with an important topic for us. It's one that we've used all year. It's one that you will continue to use even if you move into calculus, factoring. So we're going to look at the basics of factoring today. All right, so in our basics of factoring, we're going to take a look at factoring out of GCF, and then factoring a quadratic trinomial x squared plus bx plus c, and then factoring a quadratic trinomial where the lead coefficient is not just a 1, so it would look like an ax squared plus bx plus c. So let's start here. Again, factoring a GCF, a greatest common factor. Greatest common factor could be a number, a variable, or a number and a variable that each term in a polynomial have in common. And when we are factoring, it's undoing multiplication. So when you're factoring out, what you're doing when you're factoring out a GCF is you're actually using division to help yourself there. So let's take a look at a couple. All right, let's factor these. So here we go. Again, we're going to factor. We just looked at notes for factoring in GCF, so that's what we're going to try to take a look at here. And anytime you need to factor, you should always look to see if you can factor a GCF out first. If you take out the greatest common factor, if there's more factoring that happens after that, factoring out the greatest common factor is going to make your life easier. It's going to make it so that you have smaller numbers to work with. So this first one here, I'll start nice and simple. Both of these terms, 2x and 22, they're both even, so you can factor a 2 out. All right, nice and easy there. Next one over here, both of these terms are divisible by the number 5, and they also both have an x, so we're going to factor a 5 and an x out. When you try to figure out what exponent to put on the variable that you're factoring out, it's going to be the smallest exponent on all of the x's that show up here in your terms that you were factoring out from. So we factored the 5 out, so it doesn't show up anymore here because 5 divided by 5 would be a 1. X cubed divided by an x is going to leave you with an x squared. So if you really wanted to, you could put it as 1x squared, but most people are not going to put that 1 there. All right, leaving it as just an x squared. Then a negative divided by positive is still negative. 20 divided by 5 is 4, and then x divided by x is a 1, so it's no longer there. It's outside. All right, and then our next one over here, each of these terms has a y with it. They all have just a y to the first. So just a y to the first is what comes out. They all do have an x with it, with the lowest exponent being an invisible 1 up there. So we're going to factor an x out. There's not a number, a coefficient in front of all of those that they have in common, so we're just factoring the yx out. And that leaves us with a x squared minus 3x plus 2. All right, so factoring out greatest common factor, nice and easy to start off with. All right, so if you know me, you know I always like to try to show you where things come from. So before we do our next type of factoring, we're going to first FOIL these two binomials, x minus 2 and x plus 7. When we do that, when we do our first order inner last, we get our x squared plus 7x minus 2x minus 14. The outer and inner multiplications can be simplified and give us that 5x. So overall, x squared plus 5x minus 14. Okay, so where did that 5 come from? Well, that 5 came from simplifying again the 7x and the minus 2x. Well, where did then the 7 and the negative 2 come from? Well, if we would have multiplied 7 times negative 2, we would have gotten that negative 14. So that negative 14 would have been in place of our letter C, and then that 5 would have been in place of our letter B. So when we're trying to factor a quadratic trinomial, such as x squared plus bx plus c, we're going to look for factors of c that add to b. So here, when we had our x squared plus 5x minus 14, we were looking for factors of negative 14, since that was in place of our c, that added to 5, since that was in place of our b. Again, factors of negative 14 that added to 5 were negative 2 and 7. And then double checking, negative 2 plus 7, again 5. Okay, so let's try a couple. Alright, so we have two quadratic trinomials with our lead coefficient of 1, so they're in that form x squared plus bx plus c. And when that's the case, we're looking for factors of c that add to b. So factors of 16 that add to 8, that looks like 4 times 4 is 16, and 4 plus 4 is 8. So it can factor as x plus 4, x plus 4. If you wanted to, since both of those parentheses are the same, you could have written it as x plus 4 quantity squared. Alright, easy enough there. Over here, again, there's an invisible 1 in front of that y squared. So we can take a look at c. Our c value is 30. We're looking for factors of 30 that add to a negative 11. Let's see here, 5 times 6 is 30. If we make them both negative, it's going to give us a positive 30. And when we add them, we are going to get that negative 11. So that should factor right there. Anytime you are factoring, you can always make sure you got your problem correct by just going back and doing the FOIL. And yep, that would get us right back to where we started if we did go ahead and double check that there. Alright, so those last couple of problems were way too easy for you, so let's move on. Again, I always like to try to show you where things come from, so let's FOIL, again, our two binomials, 3x plus 2 and 4x minus 5. When we FOIL our first order inner last, we get our 12x squared minus 15x plus 8x minus 10. And then that negative 15x plus 8x simplifies to a negative 7x. Again, where'd that negative 7 come from? It came from simplifying the outer and inner multiplications, that negative 15x plus 8x. Well, where did the negative 15 and the 8 come from? If we would have multiplied negative 15 times 8, we would have ended up with a negative 20. Where did that negative 120 come from? Well, that very first term was a 12. Whoops, that very first term was a 12, and that very last term was a negative 10. If we also would multiply the negative 10 times the 12, we would also have gotten that negative 120. So, the 12, again, came from the coefficient of the x squared, and the negative 10 came from the constant. So, when we're going to try to factor from ax squared plus bx plus c, we're going to end up looking for factors of a times c that add to b. Alright, so we're going to do a couple here, and we're going to go with the factoring by grouping method. So here's our 3 to practice. Again, our a value is no longer just a 1, so we're going to start off with doing that a times c. Our a is a 4, our c is a 1, so we multiply those together, we get a 4. And then we're looking for factors of positive 4 that add to our b value, which here is negative 4. That would be, looks like negative 2 times negative 2 is positive 4, but negative 2 plus negative 2 is negative 4. Alright, so we've got the factors correctly there. So what we're going to do is we're going to keep the very first piece, we're going to keep the last piece, but then we unsimplify the middle term. We're going to unsimplify that middle term there using those two numbers right there. Move that over. Alright, and so then now we're going to go again with the factoring by grouping method. So what we're going to do is take a look at these first two terms and factor a GCF out of these first two terms. They're both even and they have an x. And then we take a look at the next two terms, factor a GCF out of them. They don't have both a variable or a number, but we don't usually like this first term to be negative here, so we can technically factor a negative 1 out, which then makes this become a 2x minus 1. And when we then take a look, both of our parentheses are the same. And since both of our parentheses are the same, we can take the parentheses and make it jump all the way to the front. And then inside our next set of parentheses, we're left with this 2x and that minus 1. All right, we do have the same thing twice, so if you wanted, you could write it once with the squared. Okay. All right, give us a little bit of room, get rid of that. So our next one, again, we're going to start off with that a times c. We're going to start off with that a times c. A times c, 10 times 7 is 70. Then we're going to have to look for factors of positive 70 that add to 37. And I believe that will be 2 times 35 does give us 70. And if we add them, we do get 37. All right, so we're going to keep the first piece. That was our 10x squared. Keep the last piece. But then we unsimplify the middle term. The middle term, which was that 37x. We're going to unsimplify it with those numbers there. So 2x and 35x. Then we take a look at the first two pieces. They're both even, they both have an x. So factor 2x out. And then the next two pieces, both divisible by 7. Okay. And both of those have the same parenthesis piece. So it can jump all the way to the front. And then inside the second set of parentheses, we'll have this red 2x, and then this purple 7. Okay. All right, so this last one, again, our a value is not a 1, so we're going to have to start off with that a times c, and our a times c are 12 times negative 15. That's 144, and then 3 more 12s, which is 36. 144 plus 36 is going to give us 180, and it was negative. And then we're looking for factors of negative 180 that add to 11. Wow, I need to write some things down. I know 1 and 180 will not work, but I need a place to start. 2 and 90, that's a no. 3 and 60, that's a no. 4 and 45, that's a no. 5 and goes in 3 times with 3 left over. 5 and 36, that's also a no. 6 and 30, that is a no. 8, nope. 9 and 20, there we go. If we make one of them positive and one of them negative, negative 9 times 20, negative 180, negative 9 plus 20, positive 11. All right, so we've got our appropriate factor pair. So we'll keep the first piece, keep the last piece. We'll unsimplify the middle term. We'll factor GCF out of the first two pieces. We'll factor a GCF out of the second two pieces. We're factoring 5 out. 4x minus 3. And then both of those sets of parentheses, again, are exactly the same. So it can jump all the way to the front. And inside the second set of parentheses, we are left with that red 3x and that purple 5. All right, so there's our factoring our quadratic trinomials of the form ax squared plus bx plus c, and this is considered the factoring by grouping method. All right, we have one more problem. This is not a quadratic trinomial, but let's see what we can do with this. It's cubic and it's got 4 terms. All right, let's see. All right, so I'm kind of laughing right now because I just realized this is the 9th problem that we've done, or that we will do, and it is also our last problem for today. I swear I did not plan that out at all, but it kind of fits with the baseball theme being our 9th problem, 9th inning, last problem of the day. So, we cannot, again, factor this like we were doing with our GCF. There's no GCF to factor out. The method of doing the A times C won't work because there's more than just A and C and B. We technically have an A, B, C, and D. So what we could maybe try doing is still factoring by grouping. If we just take a look at the first 2 pieces, they both have an x squared in them. And then our next 2 pieces have a 5. Okay, and then our 2 sets of parentheses are the same. And since our 2 sets of parentheses are the same, you can take that group all the way to the front. All right, leaving you with, in your other set of parentheses, x squared and plus 5. All right, so those are our factoring basics. Again, I said we would use it all year. It was really important for us, and it will be important for you even if you are moving into calculus. My Calc 2 students do still continue to have to factor. So hopefully factoring is not going to be a swing and a miss, more of a home run for you, and I will see you soon.